Nuclear fusion. In this video, we're going to understand what nuclear fusion is, how it works, why we cannot use nuclear fusion in power stations on Earth, the life cycle of a star, and how elements are formed. Nuclear fusion is the process of forcing two nuclei close enough together so they form a single larger nucleus. Energy is released when this happens. Nuclear fusion can be brought about by making two nuclei collide at a very high speed. The Sun and other stars use nuclear fusion to release energy. The sequence of nuclear fusion reactions in a star is complex, but overall, hydrogen nuclei join to form helium nuclei. An example is if deuterium and a tritium nucleus collide and they are forced together. Both nuclei are positively charged and therefore will repel each other. This is known as electrostatic repulsion. The nuclei have to get very close in order to collide, which is approximately a millionth of a millimetre. If the nuclei are moving very fast, they can overcome the electrostatic repulsion. The hotter a molecule is, the faster it will move, and the more likely it is to collide. For a nuclear fusion reactor to work, the temperature and pressure would each have to be very high. These extremely high temperatures and pressures are very difficult to reproduce and very expensive. Also, the nuclei to be fused are very difficult to contain. As a result, fusion as an energy source is a long way off. The amount of power required to generate and maintain fusion is more than the reaction can generate itself.
Gravity pulls together large amounts of dust and gas to begin the process of star formation. This is the protostar phase. Then, pressure and temperature increase within the protostar until nuclear fusion begins. At this point, the star begins to shine and it enters its main sequence. During the main sequence part of a star's life cycle, the gravitational forces pulling the materials in the star together are being balanced by forces produced by radiation. This makes the star stable. From this point on, the rest of the star's life cycle depends on the size of the star. Stars about the same size as the Sun become red giant, white dwarf, and black dwarf stars. Stars much bigger than the Sun become red supergiant, supernova, neutron star, and black hole. All the chemical elements in our solar system which are heavier than helium were made in stars that existed before our Sun. The lightest elements, hydrogen, helium, deuterium, lithium, were produced in nuclear fusion reactions. Elements higher than iron cannot be formed through fusion. You must supply energy for the reaction to take place. In the supernova explosion, neutron capture reactions take place. This is not fusion, leading to the formation of heavy elements. This is the reason why it is said that most of the stuff that we see around us come from stars and supernovae.